What if I told you that everything we think we know about aging is wrong? That it isn't some inevitable process we just have to accept? Well, today we're diving into the groundbreaking work of Dr. David Sinclair, a biologist who is completely flipping the script on how we think about getting older. This one quote right here is at the absolute heart of it all. Dr. Sinclair, over at Harvard Medical School, isn't just suggesting we think about aging differently, he's proposing we reclassify it entirely, not as a fact of life, but as a condition. And, if it's a condition, that leads to a very powerful question. Exactly. That's the billion-dollar question, isn't it? If it's a disease, can we treat it? Can we slow it down? Heck, can we even reverse it? To get to that answer, we need to dig way deeper than just the symptoms and really understand what Sinclair believes is the root cause of why we age. Right, so to cure something, you have to know what causes it. For years, the main idea was that our DNA just gets beaten up over time, collecting errors that make our bodies break down. But Dr. Sinclair's work, it points somewhere else entirely. It's not about the genetic information getting deleted, it's about our body's ability to read that information. And a key player in all of this is something called the epigenome. Now think about this for a second. Every single cell in your body, whether it's in your brain or your big toe, has the exact same DNA blueprint. So why does a liver cell act like a liver cell and not an eyeball cell? Well, that's the epigenome. It's like the director of the movie, telling each gene when to turn on and when to turn off. And here's a really important distinction to make. Your DNA, that's digital information, it's super robust, very stable, right? But the epigenome, that's analog. Think of it like a cassette tape versus an MP3. It's way more fragile and can get noisy and distorted over time. And that little difference, it changes everything. This brings us to Sinclair's big idea, the information theory of aging. The whole theory boils down to this. We don't get old because our DNA gets broken. We get old because our cells lose the epigenetic information they need to read that DNA correctly. The blueprint is still perfect, but the workers, well, they've forgotten how to read it. I love this analogy. Think about it like a CD. When you're young, it's a brand new, pristine CD. The music on it, that's your DNA, is perfect. But over the years, that CD gets handled, it gets bumped, it gets scratched. The music is still there, it hasn't changed. But the CD player, the epigenome, starts to skip and jump. And the result of that skipping is the cellular chaos we call aging. Okay, so if aging is just a scratched CD, that begs the question, can we polish it? Is there a way to help ourselves read that music properly again? Well, incredibly, the answer seems to be yes. Our bodies have their own built-in repair crew, a survival circuit designed for this exact purpose. We just need to know how to turn it on. So let's meet the heroes of this story, the sirtuins. You can think of these as a family of 7 longevity genes. They are our body's guardians, the regulators, and the emergency response team all in one. Their main job is to protect the integrity of all our information, both genetic and epigenetic. But here's the catch, the trade-off. When everything is calm, sirtuins are busy managing the day-to-day operations of our cells, keeping everything running smoothly. But when a DNA break happens, and believe me, it happens thousands of times a day, they have to drop everything and rush over to fix it. The problem is, when they leave their post, things start to get messy back at the office. Even worse, they don't always remember where to go back to. It's this distraction, this constant firefighting that scratches the CD and drives the aging process. Now, our sirtuin guardians are incredibly powerful, but they can't work for free. They need a very, very specific type of fuel to do all this regulating and repairing. And without that fuel, the whole life-saving system just grinds to a halt. And that fuel is a molecule called NAD+. It's a coenzyme in every single one of our cells, and it's absolutely critical for being alive. You can think of the sirtuins as a high-performance engine and NAD+ as the high-octane gasoline. It doesn't matter how amazing the engine is, without gas, you're not going anywhere. Now, get ready for this, because this might be the most shocking fact in this whole story. By the time we hit middle age, our levels of this critical NAD+ molecule have dropped by half, 50%. Just gone. And you can just see it in the numbers here. It's a stark reality. We start off with a full tank of gas in our youth, but that fuel gauge just keeps dropping as we get older. With less NAD+, our sirtuins just can't do their jobs properly. The emergency repairs slow down, the epigenetic noise gets louder, and aging starts to pick up speed. So let's recap. The problem is a loss of information caused by distracted sirtuins that are running low on NAD plus fuel. That sounds pretty bleak, I know. But here's the amazing part, the good news. We can actually do something about it. There are proven ways to naturally boost our NAD plus and get those sirtuins back in the game. And the master key to all of this is a fascinating concept called hormesis. It's basically the scientific version of what doesn't kill you makes you stronger. The idea is that by introducing small, manageable stressors to our bodies, we send a loud and clear signal to our longevity genes, our sirtuins, to wake up, start making more NAD+, and get to work. So what does this look like in the real world? Well, a great place to start is your plate. You see, plants that are a little bit stressed produce protective molecules called polyphenols. When we eat those plants, think things like olive oil, we get those protective signals too. And of course, cutting back on sugar and meat, and just generally eating less often are also super powerful signals. You know, that feeling of being hungry is one of the oldest and strongest survival signals there is. Now, you could try constant calorie restriction, but that's really tough for most people to stick with. A much more doable approach is intermittent fasting. Just by shrinking the window of time you eat each day, you're telling your sirtuins, hey, times might be a little tough, you better get to work protecting the body. And this isn't just about food. Things like high-intensity interval training, pushing yourself really hard for short bursts, that tells your body to get more efficient and ramp up NAD+. Exposing yourself to uncomfortable temperatures, like saunas or a cold plunge, that does the exact same thing. It activates these ancient survival programs that are hardwired into our biology. So the most important thing to get here is this. We are not trying to damage our bodies. We're trying to talk to them in their own language. A bit of hunger, a quick burst of intense exercise, a little temperature shock. These aren't insults, they are signals. They're messages that tell our bodies to get tougher, become more resilient, and on a biological level, get younger. Which, of course, brings us all the way back to the beginning. If aging really is a disease of lost information, and if we have the tools to help our bodies find that information again, well, then we really have to ask ourselves, what are the limits here? We might be standing at the very beginning of a revolution, one that could totally redefine not just old age, but the true potential of human health itself.